Right, so in this module, we're going to talk about just getting started with Python, a little bit more background about the language itself, and showing you how to get it installed on a variety of different operating systems and running our first program. So this module will get you ready really for the rest of the um, modules throughout the semester. So the first question is, what exactly is Python? And why is Python something that we'd want to learn? So first of all, if you don't know already, there are literally hundreds of programming languages. All programming languages allow a programmer, a human being, to write instructions that are to varying degrees similar to the way we write our regular language, our natural languages. Some programming languages look pretty low level. Others start to look quite a bit like the English language. So there are hundreds of them. There are literally programming languages being invented probably as we speak. And the question is, well, why would you be interested in learning Python? Um, First off, before I even talk about sort of the virtues of Python, I guess, um, let me be clear that Python isn't the best language. There is no best language. All languages have um, some good features and some bad features. All languages are very good for certain situations and probably not good choices for other situations. The good news as a programmer is that your skill really ultimately is not measured by the number of languages that you know. Your skill is a measure of your problem solving ability. And so when you learn to program and to solve problems programmatically in Python, you'll find that when you transfer that to other languages, if you ever have to write code in C or in R or JavaScript, you'll find that it's far easier to learn those languages after you've learned Python. And the same would be vice versa. So if you've already learned C++, um, Python's going to be very easy for you to pick up. And the programming skills that you've learned before that are directly transferable. So ultimately, the choice of the language that you use to learn first is probably not as critical as you might initially believe. So let's compare Python. First of all, Python is a general purpose language. What that means is that although it is certainly very good in certain situations, it's one of these languages that can be used for just about everything that we do with programming. So Python code can drive websites. Python code can do scientific, simulation. We can number crunch. We can access databases. We can do pretty much anything you can do with a programming language. We can do with Python. It's not the only general purpose language. C, C++, Java, C Sharp, and there are many others as well, are considered general purpose. That's in contrast to other languages that tend to be very highly specialized. So, for instance, if you're only dealing with, um, writing programs that deal with probability and statistics and mathematical analysis, well, MATLAB or R might be a really good choice. Now, R would not be used to drive a website. So it's a specialized type language it's really targeting that mathematical area. HTML, JavaScript, PHP, these are all languages that are highly tailored towards the web environment. You wouldn't pick HTML, and in fact, you couldn't use HTML for many of the programs that we would write in this course. And while you could probably use JavaScript, or you could definitely use JavaScript, and you could probably use PHP, it really probably wouldn't be the best fit. Those languages are tailored towards the web. Python is also a very high-level language. Generally, as a Python programmer, you don't really need to think about the bits and byte level of data. So if you remember in the last lecture, we talked about transistors and flip-flops and ands and OR gates and really the circuitry. In some languages that are very low level, like assembly, Fortran, C++, C, programmers actually find themselves dealing with the bits and bytes, the binary representations of things. Uh, Maybe not frequently, but it's not a terribly rare event either. All right, it does happen. You need to deal with those low level details. Those languages typically are going to be directly tied to the machine. We will compile them directly to a binary code, and I'll talk about the word compile later, that will run on a particular architecture. Python's much more general, much more high level. We generally do not need to deal with the details of how things are laid out in memory, taking care of our own memory allocation. These are all things, concepts that you need to take care of yourself in lower level languages. So that's a nice thing because Python's pretty accessible for a new programmer. And if you're writing a program simply to get your job done, right, to analyze a data set or to just pull some information out of the database, this frees you from having to deal with all the details all at once. Now, I will say the downside about Python is Python tends to be a little slower. The same code written in Python, if you wrote it in C or C++, chances are it would run quite a bit faster. Python is maybe even an order of magnitude slower than some of these languages. So you pay a price, but generally it's a pretty good trade-off for a lot of different applications. Finally, Python is an interpreted or and dynamically typed language. This is a little bit more more technically oriented, this difference, and you'll probably have a better appreciation of these bullet points as we proceed later on in the course. But I can say that if you've learned C, if you've learned C++ or Java, you have an idea about what compiling code really means. We take these high-level languages and we turn it into binary code, and they're statically typed in that we need to really spell out all the details of what kind of data we're using at the time when we program. Python's a little bit different. We do not need to compile to binary. We can write our code and run it through the interpreter directly, and we have a much more flexible data type system. And again, that's going to become a lot more apparent as you start to learn a little bit more about Python. But again, this is an advantage in that, again, it frees the programmer to really focus on the problem rather than the details of the implementation of the language. And then there's a price to pay, and that it does incur a runtime cost, and it's not quite as fast as some of these other languages. So what am I talking about with this Python interpreter? From the last video, I think it should be clear that while the computer generally will want to deal with binary code, that's what's going to actually run on the CPU. We as programmers don't want to write in binary. So Python is just another programming language that allows you to type in commands. All right, and this was Heron's method for calculating the square root from the last video. We might type in some Python commands that look relatively reasonable to us. We're going to send that text, that code, through an interpreter, right? A translator really. That takes that code and automatically converts it to the binary code that can run on our CPU. Right? So that's the Python interpreter. And I'll show you how to launch that and how to actually run your command. But you can see over here, this is the command line, and we're going to use that today. The command line, I type in Python 3. That's actually the name of the interpreter, and then I give as an additional command the name of my file. Right? So the Python interpreter is actually going to read the source code out of my file and then execute it. And that was the output of the program. Python, unfortunately, I've been sort of singing its praises, but it does suffer from one pretty serious issue, and that's of versions. Python is a language that has gone through a lot of changes, and unlike most languages, they have the developers of Python have not actually maintained a strict backwards compatibility. So, certainly almost all programming languages, if they've achieved any level of wide usage, they evolve over time, they change. But generally, most languages are backwards compatible. All right, so when you're installing Python, you're going to be confronted with your first question is, which version do you want to download? And when you're viewing this video, we might have moved to 3.44 or something like that, but it'll be 3 versus 2. Right? Download one or the other. We're going to be using Python 3, and it actually makes a very, very big difference. And for a second here, and if you haven't learned any other programming languages before, you can sort of ignore these next couple of slides here. But for those of you that are a little bit familiar with other languages, this is where Python's a little bit different. I think it's kind of instructive to understand the difference. So take C++, for instance. C++ is a very, very widely used language. It's been around for a good 30, 35 years now. It's used all over the world in all sorts of different areas of computer science. It's evolved. C++ today in 2015 is vastly different than the C++ from 1999 or the early 80s even. Compilers are programs that take C++ code and they convert it to binary instructions. A compiler and a Python interpreter are sort of similar, but compiling happens all in one step before we actually try to run the program. So in C++, we would compile each time we changed the code. Maybe we would only run after we were done with all of the code. Python, we can run in a much more iterative process. For C++, the new changes, the changes that continue to come out of the C++ community, all you need to do is use a new C++ compiler. So you need to download a new compiler that will take that new language code and convert it into binary. The nice thing about C++ is that the new compilers will still compile old C++ code. C++ that comes out, or the changes that have come out just recently, do not break compatibility with the older language. So if you took your source code from 1995 in C++ and ran it through a modern compiler, there'd be no problems, or typically there will not be any problems. And the binary source code that you the binary code that you would create could be run on any machine. Same thing with Java. If you know anything about Java, you know that there's a Java virtual machine, and Java code is compiled into a binary form, which is called bytecode. The bytecode itself can be run by the JVM, just like the Python code is run by the Python interpreter. Java has changed dramatically over the last 10 to 15 years, but like C++, if you take older Java code and you compile it to bytecode, a modern JVM can still run it. So it's completely backwards compatible. For Python, the difference here is that there is not backwards compatibility. For Python, both the code and the interpreter are tied to specific versions. Python version 1 is no longer really relevant, but the question is whether it's Python 2 or Python 3. So when you write Python code according to version 2, you can only run that code with the Python 2 interpreter. We're going to be using Python 3. The textbook uses version 2. There will be some differences. You're going to have to pay attention to those differences. I'll explain them as we proceed. So just to reiterate what we're talking about here, if we think about, C++ for instance, and we think about some source code that was written in 1999, and we think about some source code that was written in 2015, both of that source code from both versions could go through a 2015 compiler to produce binary code. No problem. Java, and let's say it's from 1997, and Java from 2015. Again, both are going to convert to bytecode and run on a JVM from 2015. Again, no problem. What's different here is that Python 2 code and Python 3 code require different interpreters. 3x, 2x, to binary. Okay, so why am I making such a big deal out of this? Well, first of all, like I said, the textbook is going to use Python 2, and we're going to use Python 3, and there's some aspects of Python 2 that are not able to be transported over to version 3. The other thing, and this is very important, especially as we get further along in the semester, if you go online and you look for solutions to some of your problems, I don't mean look for complete solutions, but you have a compiler error, you have a some sort of a bug that you're having. If you go online, and good programmers find lots of information online, I will encourage that you do that. The problem is that in C++, anything that you probably find will be valid, right? Whether it's from 1999 or 2015, you'll still be able to use that and incorporate it in your code. And the same thing for Java as well. In Python, if you go online and you try to get some tips and pointers, if you're looking at the Python 2 documentation, that might not be relevant at all to Python 3, and vice versa. There might be a much improved way to do things in Python 3. So you really do need to keep track of which version you're talking about when you try to find answers. Everything that I present in this course will be based on Python 3. Okay, so with that out of the way, how do we get it? So to be able to run Python code, you need to download your interpreter. So you just go to python.org/downloads. Your operating system should be detected. So when I took this screenshot, I was on a Mac. Python runs on virtually anything. So any version of Windows that you have is perfectly fine. Any version of a Mac you have, virtually every Linux distribution would be perfectly fine as well. So any operating system whatsoever. For this course, you don't need any high-powered computers or anything like that. The worst thing that's going to happen if you're using an older computer is that it's going to run a little bit slower. But that's it. So I'm just going to kind of briefly go over some of the things about the different installations. So when you get to this page, you're going to, again, pick Python 3, not Python 2. If you're on a Windows machine, you're going to download the installer and just double click on it and install it like any other program. You should be an administrator on your machine. The one thing about the Python installation on Windows, there is a screen where it asks you to customize the Python installation. Very important for convenience sake as a developer that you add python.exe to the path. Your path on a Windows machine is the directory or a path to a bunch of directories where programs can be easily found on a command line. And we're going to be using a command line to run and execute our programs, and I'll talk a little bit about that in a few minutes. So when you get to this step in the installer on Windows, make sure that you click this and select it to be installed. It should end up looking like all the rest before you click next. The location and everything like that is perfectly fine, except all the rest of the defaults. For Windows, to check your installation, you're going to open up the command prompt. So the command prompt is found in the Start menu under Accessories. The command prompt is sort of your window into directly into the computer. You're kind of bypassing the graphical user interface, and that's how you're going to run Python code. If you are not familiar with it at all, you'll become a little bit more familiar at watching what I do today in this video, but I would highly recommend if you're on Windows to visit this URL and go through the tutorial and look at how do you use that command line. The command prompt is a very fundamental tool in computer science. Most programmers use it consistently. It's simple, but it can be a little confusing to someone who's never seen it before. All right, so take some time right away before you start delving into Python to just make sure you know your way around this program to execute your code. Open up the command prompt. You can type Python. By the way, in many of my slides, or in all of my slides and videos, I'll be typing in directly Python 3. On a Windows machine, if you install Python 3 and you do not have Python 2 installed, you can just use Python. If you already have Python 2 installed and you try to install Python 3, you're probably going to need to use Python 3 when you type it in. For a Mac, actually, before I go any further, when you type in Python, you should see the version string come up here and a prompt. You can just type in exit open and close parentheses. That'll exit out of that Python interpreter. Python, and we'll see a little bit of this later on, and the book uses it consistently. Python allows you to type in commands directly into the interpreter this way. Typically, we'll launch Python with a file as well. So you should see something like this on Windows to make sure that your installation is correct. On a Mac, you can just download the package file from the same website. Accept all the defaults. There's no need to deal with the path that's set up automatically for you. So that's a pretty easy installation. On a Mac, if you want to test whether your Python works, open up Terminal. Terminal is essentially the same thing as the command prompt on a Mac. If you're not sure where Terminal is, just hold down the Apple key, the command key, and space, and type in Terminal, and you'll find that it'll come up. For a Mac, you definitely, the installer installs Python as Python 3. So you're going to open up the terminal, type Python 3, hit enter, and again, you should see something, especially this version string, something like 3.4. It might be 3.5, it might be something else, but it should start with a 3. All right, that's the most important part. If you're on any other system, so if you're on Linux, generally if you're on a Debian-based system with apt, you can just type in apt-get install Python 3, and that should work perfectly fine for you. If you're on other distributions, really a web search just to how to install Python 3 is probably the easiest way to go about this. If you have any problems, just let me know. I'm happy to help you. Most of the videos that I've done have been recorded on Linux, so it certainly works perfectly fine. You shouldn't have any problem. Okay, so let's actually demonstrate writing a little bit of code. So first off, the Python interpreter that we just installed doesn't contain any code, right? So you can't run programs. You have to actually write some source code. You're going to point the interpreter to the file that you have your source code in, and the interpreter is going to read that file and execute your program. So you need some sort of a program to write your source code. You could write Python in anything. You could write Python in Notepad if you wanted to. But you really need a source code editing program. And there are many out there. They're free. Anything will do. I use Sublime Text in the videos. It's for non-commercial use. You don't need to purchase it. You can certainly purchase the license for, I think it was about $70. That's totally up to you. GitHub's Atom editor is also a very nice choice. That's free. That will work with Python. And what these programs will give you is syntax highlighting. It'll help you, and you'll see what I mean as I start to type this. It'll help significantly. So you definitely want to download one of these and install them. I would then create a directory on your computer to put all your source code in throughout this course. Probably a good idea to keep it all in one place. So a Python program consists, and we've already seen a little example of this with the square root program, but it just consists of a line of commands telling the computer to take some action. Some of these actions are visible, so when they're executing, a print statement will actually print something to the screen, and you'll see it happen. Right? You'll see it on the command prompt or on the terminal. Other commands are invisible to the programmer, right? So I might have 100 different lines of Python code, but maybe my program doesn't print out anything at all. Doesn't mean there's anything wrong with my program. I'm probably doing things like, creating data, reading data, number crunching, something like that. But right now we're just going to do a very, very basic program that just prints out the typical hello world. So I'm going to flip over to Sublime Text. So this is my text editor, and I'm going to create, I already created, I did file, new file, and I'm just going to type in some simple Python code. All right, so I'm going to say print hello world, and you'll notice that it's just white font color. I'm going to do save, And I'm going to save this, and this is, again, you'll have a different dialog if you're on Windows or a Mac, but I'm going to save it in my projects folder under CMPS 130, under course, under lecture. I already have a file here. I'll say hello.python. The extension is .py is important. It's not particularly required to run your code, but once you save your file with a .py extension, if I hit save, Sublime Text now understands what you're typing. It understands the language that you're using, and it'll start doing some syntax highlighting. And this is going to become very, very useful for you as your programs get bigger in the next few videos. Right now, it's not terribly important. So I've saved the file. Right now, I can't execute the program. So this is just a simple text file binary code, text ASCII code. So I'm going to open up my terminal. Right. And so again, I'm on Linux, so this looks one way, and on a Mac it would look a little bit different. On a Windows machine, you'd be using the command prompt, which has some slightly different commands. So I'm going to start off by typing ls, and that's going to tell me, what's on my actual computer in this directory. In fact, if I type pwd, it'll tell me that I'm in the home sfreeze directory. ls and pwd will work on a Mac. If you're on Windows, what you want to do, instead of ls to list all the files in your current directory, you would type dir. It's not going to really work on Linux, but that's what you would type for a Windows machine. And again, please look at that tutorial to familiarize yourself with that. If you're on a Mac and you haven't used a terminal, on the module webpage for this course, for module 1 in the materials section, there's some links for using the terminal on a Mac as well. So I'm going to change directories using the cd command into projects. On Windows, it's the same command, cd. I'm going to do cd space CMPS 130, cd space course, cd space lecture. And if I type in ls, I can see my hello py file. Again, on Windows, you would do the same exact structure into whatever directory that you save this stuff to. And to list the directory contents, you would type in dir. To run my program, I'm going to type in Python 3. All right, so if I was just to launch that, I would just get something like this, and I'd get the Python interpreter ready for commands. I don't want to do that. I'm going to type in exit, open and close parentheses. But if I type in Python 3, followed by the file name, and it's very important that I'm in the directory where my file is, now Python will actually go and run my hello.py file. Right? And what it's done is it's printed out hello world to the screen. Now if I go back over here, and type in this is my first program, notice, and this is different with every source code editing program, but for Sublime Text, you'll probably have some sort of an indication. This blue line tells me that I have unsaved work. Until I save the file, I can keep running this as much as I want. It doesn't change, right? So make sure that when you change your code, you save it. And Control S on Windows, Mac, or Linux will work to save it. And you can see that that saved. And when I rerun the program now, I get my changed command. And I can do many commands, right? So, and this is a pretty simple program just with some print statements. Okay. So for the remaining set of modules in this course, we're going to be learning about what you can do in this source code, right? What you can write in Python. In terms of running your programs, it'll be exactly the same for every single program that you write from here on in. So if understanding the command prompt seemed a little strange to you for a while, for this first time, don't get too alarmed by that the first time anybody sees the terminal. It's a little mysterious and a little confusing. You'll get the hang of it, and once you do, rest assured it'll be exactly the same all the way throughout the rest of this course. So it shouldn't be a big problem for you. So what if this didn't work? First off, before you move on at all in this course, you need to do what I just did. You need to write a Python program to just print out your name, print out hello, something like that. Anything that you want to do, and you can go through the slides for more detailed instructions. You must be able to run your Python code. Don't bother going to even the next module, the next slides of this module until you can run your Python code. If you have any issues, please reach out and email me and get in touch with me. I can try to help you. But your first line is basically to go through and make sure you haven't skipped any steps. You've downloaded everything correctly.